Hello there, this is Dr. Engineer. Today we are going to see into Introduction to Consolidation in Soil Mechanics. What is consolidation? Consolidation is any process which involves a decrease in water content of saturated soil without replacement of water by air. What does that mean? When we apply a load on a soil sample, for example in a one-dimensional consolidation test, the soil has three phases, that is the water, air and the solid phase. The air in that phase is replaced by water eventually due to the load present on the soil, and the soil becomes settled down. We should note that this process is a slow process under static load which takes a longer time. So consolidation is a tricky process. It takes long time under static load. There is a replacement of water, and there's another similar process which is compaction, but it is a rapid process. There's dynamic load application and the process is quick. So this consolidation process can be divided into three portions known as the initial compression, primary consolidation and the secondary consolidation. So what is initial compression? Initial compression is the amount of settlement which has already occurred due to the previous applied loads. Now when we consider the graph between settlement and time in log scale in semi-log plot, the portion above this line, this is the initial compression which has already occurred due to the load it has previously experienced. Now as per the load applied now, the primary consolidation process starts where the water gets expelled from the soil due to the addition of the load, and the soil starts to settle down. So once the primary consolidation process is almost over, the secondary consolidation process starts, which is below this line, where the soil matrix gets rearranged and the soil settles furthermore. But comparatively, this is fast process than the secondary compression, which is a much slower process. One should note that to find out the point where almost 100% settlement of primary consolidation occurs is to draw a tangent along this line, which is something like this, and draw another tangent along this line of the secondary consolidation portion, extend it, and where the points meet gives you the settlement delta 100, where the primary consolidation process is almost over. Here this portion is the point which is the settlement which has occurred, which is known as the immediate settlement. Furthermore, we can find out the zero settlement using the Casagrande method, which we will be seeing in the upcoming videos. Here, another important point is that always one should remember that primary consolidation and secondary consolidation can occur simultaneously. So before ending of primary consolidation, the secondary consolidation process begins. So it does not mean the primary consolidation process has to completely end before before starting the secondary consolidation process. So we should remember that that is an important point. So the next theory we are going to see under the introduction of consolidation is the spring analogy. The spring analogy is a very easy concept we can use to study how the soil experiences the load under drained and undrained condition based on the principle of effective stress. Now this is a simple diagram where it represents a piston and a spring which is similar to the soil, the fluid which is similar to the water present. The piston hole, so the tiny hole here will be the drainage path, and the piston is to apply the stress. So this test can be performed in two conditions, which is undrained, the second one is drained. So under undrained condition, the tiny hole will be always closed. So you can understand when the valve is closed, there will be no drainage. So once we apply the load, so the spring cannot compress. As the spring cannot compress, the load has to completely transfer into the water. So the pore water pressure U spikes up by a certain amount and remains constant throughout the entire process. So once the U increases, the total stress experienced also should increase and remain constant throughout the practical. But the effective stress do not change since the soil does not experience any stress due to there is no drainage. In the drained case, this is bit different because at the initial stage when we are applying the load, the valve will be closed, so which is similar to the undrained condition, and once the valve is opened, drainage occurs, thus allowing the water to escape. So spring compresses. So which is similar to the process in consolidation where the soil experiences the load. Now as the water is allowed to escape, the pore water pressure decreases through time. So as it spikes up and it starts to decrease with time. So once the pore water pressure starts to decrease, the spring starts to compress, thus increasing the stress, effective stress onto the soil. So the effective stress starts to spikes up. So once the pore water pressure decreases to the initial value, the piston no longer moves up. So these two situations occur at the same time. So after this, there will be no any pore water pressure to dissipate. So the pore water pressure remains the same and the effective stress also remains the same since the spring will be at the same location. So there are two different graphs. One is for the drain condition, one is for the undrained condition, and one is for the drain condition. This is undrained and this is drained. So this is undrained, sorry, this is drained, and this is for the undrained. For both the cases, the total stress graph would be same. So drained and undrained. So this is the way how the soil experiences the stress once the load is applied to it. So the next thing I want to introduce is to the settlement occurred before and after the consolidation process. Right. This is a simple three-phase diagram of a soil sample performed in the one-dimensional consolidation test. This before consolidation and after consolidation. Here the height of solid is taken as HS, which is same for both the situations. Here the water height is HWF after consolidation, and here the water height is taken as HW here. And here the ratio is taken as, sorry, the settlement is taken as delta, and this ratio is taken as 1, and this entire is taken as EF, and here this entire portion is taken as E naught, and this height is taken as HA. So we are going to find the settlement delta. So we know that void ratio is equal to volume of voids over volume of solid. So E void ratio E naught for before consolidation is equal to VV over VS. So VV can be written as cross-sectional area of the sample into height of void over cross-sectional area of sample into height of solid. So since this is a one-dimensional consolidation test, the sample is in the cylinder shape, so simply it's cross-sectional area into height. So as the cross-sectional areas are same, so it gets cancelled out. So HV, the height of void, can be written as the height of void, which is this portion HA plus HW. This can be written as the total height of the sample, which is the capital H, minus simple HS, which is the height of solid. So this can be written as H minus HS. So over HS, this is E naught by 1. So simply at the bottom portion of denominator to the numerator, so E naught plus 1 is equal to capital H over simple HS. So HS is equal to capital H over 1 plus E naught. So we now know the HS in terms of capital H and the initial void ratio. So after consolidation, the void ratio EF is equal to, again, this can be written as HV over HS from this step. So we know HV can be written as, in this case, HV can be written as capital H minus HS minus delta, since this is the only void portion available. So HV is equal to capital H minus HS minus delta over HS. So I am dividing these portions separately. So EF is equal to H minus HS over HS minus delta over HS. So here this entire portion, we know what is the value, that is E naught. From here we can write as EF is equal to E naught minus delta over, from the result we obtain here we can write as H over 1 plus E naught. So delta over H into 1 plus E naught is equal to E naught minus EF. So delta is equal to delta E over 1 plus E naught into capital H. So this delta E can be represented in the three-phase diagram, which is this portion. The change in volume, the delta E, the change in volume occurred while the consolidation process. So this is as simple as that. It's a very simple thing, so it's easy to understand. So I want to explain one more thing, which is a very important concept, especially when it comes to further advanced soil mechanics and geotechnics. It's the normal consolidated and over consolidated clay. Note that these are not clay types. For example, montmorillinite, kaolinite, these are clay types but not normal or over consolidated clays. These are clay types of clays, right? The normal consolidated clays, for example, millions of years back when the first soil was formed, it would have been formed in a layer, and again there would be another layer formed after thousands of years. Eventually there would be layers and layers forming above one another. So the soil which is at the bottom, let's consider this soil matrix. For every new layer formed, the stress experienced by this soil element would have been increased. So any soil which is experiencing the maximum stress at this very moment while we are recording this is known to be the normally consolidated clay. Maximum stress at this moment. So when you consider its soil history, this sigma, this value would be the maximum stress it would have been experiencing. When you come into over consolidated clay, so let's say there are a few layers of soil. You are considering the soil here. So for any type of construction, let's say for a construction of a two-story building, you are making an excavation here and removing this soil. So when you consider this soil in its soil history, before removing this soil, it would have experienced a stress, let's say sigma 1. After removing, so now the soil has been removed, so now let's say the stress is sigma 2. Obviously we know sigma 1 would be greater than sigma 2, and sigma 2 is the stress it is experiencing now. So this stress sigma 2 is lesser than sigma 1. So when you consider its soil history, now at this stage it is experiencing sigma 2, which is a smaller stress than it has experienced in its soil history. So there is a higher stress which it has already experienced in the soil history than what it is experiencing now. So these types of clays are known as over-consolidated clay. So in our one-dimensional consolidation laboratory test, after performing the entire test, we would draw a graph for the void ratio E and the effective stress sigma in a semi-log plot. This would be in the log scale. So if we randomly draw a rough sketch of this output graph, this graph section can be divided into three portions. Three sections. So this would, in this region, this clay would behave as over consolidated, and in this region the clay would behave as normally consolidated, and in this region the clay would again change into over consolidated. So there's a reason for this. So I will try to explain this in more detail when we study and do a video based on the one-dimensional consolidation laboratory test. I want to mention that a single clay material can change from a over-consolidated state to normally consolidated state and again back into over-consolidated state. That is the thing I want to stress here. That is, normally consolidated clay and over-consolidated clay. These are not clay types, these are just states of clay that it can change from one another. For an example, these are like solid, liquid and gas state of water. Water can be in a solid state, liquid state and in gas state. Similarly, a clay can be in normally consolidated state and it can change into over consolidated state, and even it can again come back into normally consolidated state. It can change from one state to another state. Please keep that in mind. These normally consolidated and over consolidated are just states of clay. I hope you would have gained some knowledge from this tutorial. Like, comment and subscribe to my channel and turn on the bell icon to get the future notifications, and comment down any requests you all need me to do. Thank you.